What if I told you that everything you have ever seen, everything you have ever touched, every star in every photograph, every galaxy ever captured by every telescope ever built, every single atom inside your own body, is only a tiny fraction of what is actually out there? The rest is invisible. It is massive. It is everywhere. And for most of human history, we had no idea it existed. If this video earns your attention, it will change the way you look at the night sky forever. So here is the deal. If you want to keep uncovering the biggest secrets the universe has been hiding, hit that subscribe button right now, drop a like if you believe the truth is worth chasing, and share this with one person who loves asking big questions. I will be here every single week pulling back the curtain on the cosmos. Now, let me take you somewhere strange. Picture this. You're standing outside on a clear night. You look up, you see thousands of stars. It feels like everything. It feels like the whole universe is right there above your head. But here is the uncomfortable truth. What you are looking at, all of it combined, makes up only about 5% of what is actually there. 5%. Everything we have ever known, everything humanity has ever measured, every planet, every moon, every cloud of gas, every black hole, every particle that makes up your coffee cup and your heartbeat, all of it, 5%. The other 95% is something else entirely, something we cannot see, something we cannot touch, something that does not behave like anything we have ever studied. And here is the part that should give you chills. We only know it exists because of one woman who refused to look away when the numbers stopped making sense. Her name was Vera Rubin. Now, before we get to her, we have to understand the problem she was staring at. Because the problem is the real villain of this story. It starts at the very beginning of everything. When the universe was born, when all of space and time exploded into existence, matter started clumping together. Stars formed. Gas clouds swirled. Galaxies took shape. And right away something was off. Galaxies were forming too fast. They were holding together too tightly. They were spinning in ways that the laws of physics said they should not be able to spin. For decades, scientists noticed this. They ran the numbers. They saw the problem. And then, quietly, they moved on. Because when the math does not work, the easiest thing in the world is to assume you made a mistake somewhere. The second easiest thing is to just not talk about it. Vera Rubin did neither. Born in 1928 in Philadelphia, Vera was a kid who looked up at the night sky and felt something most people never feel. Not just wonder, questions, hundreds of them, questions that would not leave her alone. Her father, an electrical engineer, saw this spark in her and fed it. When she was a teenager, she built her own telescope out of cardboard and spare parts. She would drag it to her bedroom window and watch the stars drift across the sky, night after night, tracking their movements like a detective tracking a suspect. This was not a child playing pretend. This was someone who had found her life's work before she was old enough to vote. Here is where the story takes its first sharp turn. Vera graduated from Vassar College in 1948. She was the only astronomy major in her entire class, and she was brilliant. She wanted to keep going. She applied to Princeton University, which had one of the best graduate astronomy programs in the world. Princeton said no, not because her grades were weak, not because her work was unimpressive. Princeton said no because Princeton did not allow women into its graduate astronomy program. Full stop. That policy would not change until 1975. Think about that for a moment. A policy that kept half the human race out of one of the greatest scientific institutions on Earth, for decades, simply because of their gender. So Vera did what she would do her entire life. She went around the closed door. She earned her master's degree at Cornell. Then she moved to Georgetown University for her doctorate. Every time the world slammed a door in her face, she found a window, and she kept walking through them. For her doctoral thesis, Vera studied how galaxies are arranged in space. And she made a real discovery. Galaxies are not scattered randomly. They cluster together, gathering in groups, pulled by forces we could barely understand. She wrote up her findings and sent them to the most respected astrophysics journal of the time. And here is what happened. The editor rejected her paper. Not because it was wrong, not because the science was bad, because the editor's own student was working on the same topic, and he wanted to protect his student's work. A woman's original research, buried by office politics. She kept going anyway. Now, this is where the story gets truly extraordinary. By the 1960s, Vera was working at the Carnegie Institution in Washington, D.C., and she made a decision that would quietly rewrite the laws of physics. She decided to study spiral galaxies, specifically how fast they spin. On the surface, this sounds simple, almost boring, but it had enormous implications. Here's the physics you need to understand. In our own solar system, the planets closest to the sun move the fastest. Mercury zips around in just 88 days, screaming along at incredible speed. Neptune, way out at the edge, crawls. It takes 165 years to complete a single orbit. This is not a mystery. It is basic physics, going all the way back to Kepler and Newton. The farther you are from the center of mass, the slower you move. The closer you are, the faster you go. Every scientist on Earth knew this. It was settled science. It was as obvious as gravity itself. Now, apply that same logic to a galaxy. A galaxy is a giant spinning disk of stars. The stars near the center should whip around quickly. The stars at the outer edge should crawl, just like Neptune. That is what the math predicted. That is what everyone expected to find. It was so obvious that nobody even thought to check. In 1965, Vera Rubin became the first woman to work at the Mount Palomar Observatory in California. She teamed up with an instrument builder named Kent Ford. Together, they built a spectrograph, a device that could measure the speed of stars by analyzing their light. And they pointed it at galaxy after galaxy, starting with Andromeda, our closest giant neighbor. What they found broke the universe. The stars at the very edges of these galaxies were not crawling. They were screaming around at the same speed as the stars at the center. The outer stars should have been slower. The math said so. The physics said so. But they were not. They were moving just as fast, sometimes even faster. It was like watching a spinning record where every single point moves at exactly the same speed. That should be physically impossible. Unless something else was there. Something invisible, something massive, something pulling on those outer stars with a gravity that no telescope could see. Vera did not just find an anomaly. She found the first direct evidence that the universe is mostly made of something we cannot see. Something we now call dark matter. Now, here is the moment that separates Vera Rubin from every scientist who came before her. Other researchers had noticed these curves. A few had even measured them and quietly filed the results away. But Vera did something almost nobody else had the courage to do. When the data did not match the theory, she did not assume the data was wrong. She asked a different question. What if the math is right and our understanding is wrong? That single question is the difference between a good scientist and a great one. The willingness to trust the evidence over the assumption. The willingness to say, maybe the universe is not broken, maybe we are. Now, here's a beautiful detail. Vera did not invent the term dark matter. The phrase had floated around at the edges of science for decades, tossed around by a few curious minds. But Vera Rubin is the one who proved it was real. She measured galaxy after galaxy after galaxy. 60 spiral galaxies. Every single one showed the same result. The speed of the stars did not drop off at the edges. It stayed flat. Scientists call these flat rotation curves now. And the only explanation, the only one that works mathematically, is that every galaxy is wrapped in a massive, invisible halo of matter. The numbers are staggering. In a typical galaxy, there's about 10 times as much dark matter as visible matter. 10 times. Every galaxy you have ever seen in a photograph, the Milky Way, Andromeda, every spiral and every ellipse is like an iceberg. What you see is just the tip. The vast, invisible bulk underneath is dark matter. And when you zoom out even further, the numbers get even more humbling. Scientists now estimate that ordinary matter, everything we can see, makes up only about 5% of the universe. Dark matter makes up about 27%. And the rest, roughly 68%, is something even stranger. Something called dark energy, a force that is actively pushing the universe apart, accelerating its expansion in defiance of gravity. We will come back to that, because it matters, and because it is about to become the biggest story in science. Here is a bet I am willing to make. By the end of this video, you will never look at the night sky the same way again. And if I am right, hit that subscribe button so you never miss the next story that changes how you see the world. Drop a like if you're ready to keep going. And share this with one person who still believes the universe is full of secrets worth chasing. But first, let me tell you about the price Vera paid for what she found. Here is the part of this story that should haunt you. Dark matter is one of the most important discoveries. It changed our understanding of the universe at the most fundamental level. It spawned entire fields of physics, and many scientists believe Vera Rubin deserved the Nobel Prize for it. The prize never came. She died on December 25, 2016 at the age of 88 without receiving the field's highest honor, and the scientific community has long regarded that as a glaring injustice. Emily Levesque, an astronomer at the University of Washington, put it this way: "The existence of dark matter has utterly revolutionized our concept of the universe and our entire field. The ongoing effort to understand dark matter has spawned entire subfields within astrophysics and particle physics. The Nobel Prize in Physics is meant to recognize the most important discovery in the field. If dark matter does not fit that description, nothing does." Vera received the National Medal of Science. She received the Gold Medal of the Royal Astronomical Society. She received the Gruber Prize in Cosmology. She was elected to the National Academy of Sciences, only the second woman astronomer ever to receive that honor. But the Nobel, the one prize the entire world recognizes, was denied. Not because her discovery was too small. It was the biggest. It was denied because of a system that never fully saw her. And here's the thing that makes her unforgettable. Vera herself never complained. She was characteristically gracious about it, always turning the spotlight back to the science. "Fame is fleeting," she once said. "My numbers mean more to me than my name." Read that line again. "My numbers mean more to me than my name." That single sentence tells you everything about who Vera Rubin was. She did not chase dark matter for recognition. She chased it because the universe was lying to everyone, and she refused to let it get away with it. Now here is where this story reaches into the present. Because Vera's work did not end when she died. It is only now, right now in 2026, that the full scale of her legacy is beginning to unfold. And it is enormous. In 2019, the Large Synoptic Survey Telescope was renamed the Vera C. Rubin Observatory. It is the first United States national observatory ever named after a woman. It carries her name because no name fits better, because this observatory was built to hunt the invisible. On June 30th, 2026, the Rubin Observatory officially began its 10-year mission. It is called the Legacy Survey of Space and Time. And it is the most ambitious survey in human history. A single telescope perched on a mountaintop in Chile, scanning the entire southern sky over and over, every single night for a decade. It is not taking a few pretty pictures. It is making a movie. An ultra-wide, ultra-high-definition cinematic record of the entire universe, changing every night. The heart of this machine is the largest digital camera ever built for astronomy. It has 3.2 gigapixels. To put that in perspective, your phone camera might have 12 megapixels. This camera has 3,200 megapixels. It can capture a patch of sky the size of 40 full moons. And every single night, it sends out roughly 7 million alerts. 7 million. That is 7 million new cosmic events detected in the previous 24 hours. Supernovas exploding, asteroids drifting, stars flickering. The sky is not static. It is alive. And for the first time, we have an instrument that can watch it breathe. More than 17 billion stars in our own Milky Way, cataloged in detail. About 20 billion galaxies mapped and measured. Around 10 million supernovas, exploding stars analyzed. More than 1,000 of them every single night. This is not science fiction. This is happening right now. The data is flowing. The discoveries are beginning. And here's the question cosmologists are asking. The Rubin Observatory was built to settle one of the greatest debates in modern physics. Is dark energy constant, or is it changing? Remember that 68% I mentioned earlier. Dark energy is the force that is pushing the universe apart, accelerating its expansion. Albert Einstein first imagined something like it, a cosmological constant, a kind of cosmic repulsion. Then he called it his biggest mistake. Then, decades later, astronomers discovered the universe is accelerating. Suddenly, Einstein's constant did not look like a mistake at all. It looked like the answer. But some scientists believe dark energy is not constant. They believe it has been changing over time. And if it is changing, then every model of the universe we have built is wrong. The standard model of cosmology, the foundational theory, would need to be rebuilt. That is a terrifying and thrilling possibility. The Rubin Observatory will finally tell us which one is true. Here is another way Rubin will hunt the invisible. Through something called stellar streams. These are rivers of stars, the ghost trails of galaxies that were torn apart by gravity billions of years ago. They stretch across the sky like glittering threads, and they are sensitive to tiny gravitational nudges. If dark matter is clumped in certain places, it leaves a fingerprint in these streams, a distortion, a gap, a kink in the line. And now we have a telescope powerful enough to read those fingerprints. Rubin will not work alone. By the late 2020s, it will be joined by the Roman Space Telescope, scheduled to launch on August 30th, 2026, aboard a SpaceX Falcon Heavy rocket. 2 observatories, one in Chile and one in space, working together, combining their data to answer questions. Is dark energy changing? Is the fate of the universe different from what we thought? Together, these 2 machines may finally give us the answer, and the hunt is accelerating. Scientists at Johns Hopkins have been investigating a mysterious gamma-ray glow at the heart of our galaxy. A glow that could be the signature of dark matter particles colliding and annihilating each other. 2 invisible particles slamming together, releasing a burst of gamma rays. If that signal holds up, it would be the first time in history that human beings have directly detected dark matter, not just measuring its gravitational pull, catching it in the act. Pause this video for 5 seconds. Look at your hands. Every atom in them came from a star that exploded billions of years ago. You are made of the 5%, and the other 95% is flowing through you right now. If that does not make you want to understand the universe better, nothing will. So subscribe and like. Then come back next week, because we are just getting started. Deep underground, other experiments wait. The LZ detector, buried under a mile of rock, is hunting for weakly interacting massive particles. These experiments cool their detectors to near absolute zero, then sit and wait for a brush. 1 interaction. That is all they need to confirm the most important discovery in physics. If we catch a dark matter particle in the act, it would not just win a Nobel Prize. It would rewrite the story of everything. It would tell us what the universe is mostly made of. It would tell us whether the shadow world around us is simple or complex with its own chemistry, maybe even its own structures we cannot begin to imagine. For the first time, we would hold the invisible. Some scientists now believe dark matter might not be one thing at all. It might come in two forms, two types of dark matter, not one, perhaps an entire dark sector, a shadow universe of particles. A parallel physics happening everywhere, passing through your hand, through this planet, without a trace. And there is an even stranger idea on the horizon involving radio signals from the early universe. Missions on the far side of the moon could reveal the fundamental properties of dark matter. We are putting radio telescopes on the far side of the moon to listen for the whisper of dark matter. Signals from the beginning of time, the cosmic dark ages, might contain the fingerprint of dark matter. And if we can read that fingerprint, we might finally understand what it is. Vera Rubin once wrote, "Still more mysteries of the universe remain hidden. Their discovery awaits the adventurous scientists." She wrote those words with no idea that the future would be using an observatory built in her honor, carrying her name on the side of an 8.4-meter telescope on a mountaintop in Chile. Pointed at the sky every night, scanning billions of galaxies, looking for what she proved exists. She had no idea her name would be stamped on the greatest hunting instrument in human history. She just did the work. She just trusted the numbers. She just refused to stop. In 2025, the United States Mint released a Vera Rubin quarter as part of the American Women Program. Her face now sits on American currency. Think about the distance between those two moments. A homemade cardboard telescope in Philadelphia and a face on a coin. That girl changed everything. So let me leave you with this. Right now, about 95% of the universe is a total mystery. We have no idea what it is, except that it is weirdly different from any matter or energy studied. The stuff we do know, the stars and planets, all of it, is a scant 5%. Vera Rubin found the first crack in the wall between what we understood and what is out there. She did it with data and a willingness to believe the universe over the textbook. She was denied Princeton. Her research was buried by an editor. She watched men receive Nobel Prizes for smaller discoveries, and she kept going. For 50 years, she kept going. Think about what that persistence costs a person. Every rejection, every closed door, every prize handed to someone else, every time she had to prove herself. She could have quit 1,000 times. She could have decided the universe did not want her. Instead, she decided that the universe was worth fighting for. That decision is why we know what we know. The Rubin Observatory scans the sky every night, collecting data that will take scientists decades to analyze. Somewhere in that data, in the shapes of galaxies distorted by invisible mass, is the answer. What is the invisible thing holding everything together? We do not know yet, but we are closer. We are only here because one woman refused to accept that the universe was allowed to keep secrets. The most powerful telescope in history bears her name. The most important survey is running right now. The mystery she cracked open is still the deepest, most important scientific question of our time. 95% unknown. One woman who changed what we know about the 5%. And a machine named after her that may finally tell us what the rest of it is. The universe has been hiding something for 14 billion years. Vera was the first to prove it. And now, for the first time, we might finally be ready to find out what it is. If this story moved you, subscribe so you never miss the next chapter. Like this video so the algorithm knows truth matters. And share it with someone who needs to be reminded that one stubborn person can change everything. Because the next Vera Rubin is out there right now, and she's probably watching this video. The universe is still hiding its secrets, but not for much longer.